Good morning. Welcome to Mission Control Houston. We're here inside the Space Station Flight Control Room. I'm Brandy Dean. I work in public affairs here at NASA, and I've got here with me Stan Love, one of our astronauts. He's been to the International Space Station on board a space shuttle, and now is working on a lot of kind of future planning activities for what's next for NASA. So, Stan, why don't you tell us a little bit about yourself?
Sure. My name's Stan Love. I joined NASA in 1998 as an astronaut. Before that, my background was in physics, astronomy, planetary science, and spacecraft design. Um, since then, I've done a bunch of jobs here at NASA, including working as a Capcom here in Mission Control and in our other control centers here at Johnson Space Center. Spent about 8 years doing that, so I'm used to sitting at another console in this room.
And Capcoms are the people here on the ground who get to talk to the astronauts when they're in space.
Yeah, so when you hear a voice saying, ISS Houston, such and such, that's the Capcom speaking. So I also flew in space on Space Shuttle mission STS-122. That was in 2008. I did a couple spacewalks, worked the robotic arm on the shuttle and on the station, and my crewmates and I installed the Columbus laboratory module onto the space station, which is still there today, right on the front where it's easy to see. And I'm with you here today. I'll be happy to answer your questions about space travel.
So, if you're ready, we can go ahead and start taking your questions.
Okay. What do astronauts do in space to negate the effects of microgravity?
Okay, what do astronauts do to try to mitigate the effects of microgravity? Quite a lot, actually. They spend at least 2.5 hours every single day in space doing mostly physical exercise to help counteract the effects of gravity. Of course, your body is like anything else that's precious. Use it or lose it. So when you get up into space and you get out of the effects of gravity, you don't have to carry your body weight up and down stairs and things like that. Your muscles get real weak. Your bones can get real weak. A whole bunch of other things happen. In order to keep your muscles and bones strong, then you have to do a lot of exercise to try to make your body work as hard in space as it has to every day on Earth. You don't even realize how much work you're doing just standing up and moving around. So the astronauts will be doing the equivalent of lifting weights. Of course, you can lift a lot of weight on the space station. It's not much of a workout because there's no gravity. So instead, they've got a weightlifting machine that instead of pushing a big weight, you're pushing against a cylinder of compressed air. They also have a treadmill for running. Of course, you don't stay on the treadmill in weightlessness, so you have to have a bunch of bungees to hold you down, make you feel like you're running on a surface on Earth. And again, they're hard scheduled for that 2.5 hours every day to try to keep them in good shape. In the early history of the space program, especially the Russians who were doing long duration space flights before the United States was, crew members who didn't exercise came back and were in pretty poor physical shape. It took them a long time, a lot of rehab on the ground to get back their strength and their bone density. But we're finding that our crews are coming back from station in pretty good shape because they're doing their exercises.
And actually, if you're really interested in that, you can find out more about some of the workouts that astronauts here on the ground and also in space do with our Train Like an Astronaut program. Mike Hopkins, who just launched to the space station yesterday, has been real involved with that, and he's been sending down some tips, and we have some suggested workouts for you. And you can find out more about that on Facebook at facebook.com/trainastronaut. You can see that address on the bottom of your screen there. Next question.
What materials, like on the outside of the space station, are used, like to keep it, I guess, safe? And are there better materials that you can use that you simply can't get up there right now, or it can't be, or you can't afford right now?
Okay, the outside of the space station, to keep it safe, you said, the main threat to the space station and the crews living on board is orbital debris. You'll hear us sometimes at NASA use the phrase MMOD, which stands for micrometeorites and orbital debris. But up where the station orbits, there is actually not very much micrometeorite. It's almost all orbital debris. That is stuff that we have put up there, either accidentally or on purpose. It's orbiting around the Earth at enormous speeds, much, much faster than a rifle bullet. So to keep the station safe, it has what's called a debris shield. So instead of just having your hull of your space station, which is a single wall of aluminum, out there facing the orbital debris where if something hits it, it could punch a hole in it, we put a second wall around the whole space station and stood out from the inner wall by a few inches to maybe a foot. And what that does is when a piece of orbital debris comes in, it's coming in so fast that if it hits anything, even something as thin as a sheet of tissue paper, that projectile is just going to break up into a spray of molten droplets and little tiny fragments. And then that stuff spreads out over the intervening gap between the debris shield and the main hull of the space station, so that when it hits the main hull, it's all spread out and doesn't punch a hole in it. So that's how you protect against really high-speed stuff. So it doesn't really matter what the material is. You can make strong armor or something like that. And at the speeds of collision that we're talking about, it really makes very little difference. The important thing is to have that shield, can be very thin, doesn't matter what it's made out of, stood off from your main pressure hull. The actual material that we use for all of that is aluminum. That's what aerospace engineers, the folks who go to work here at NASA, were trained to use when they were in college studying to be aerospace engineers. Aluminum's what we're used to. It works pretty well. It's also really light, which is important because everything has to be launched on a rocket, and we can just barely shave down the masses of all the stuff we throw into space enough so that the rocket can actually lift it up into orbit. So aluminum's a good choice. I don't think we have anything waiting in the wings that's like a super armor that would be better. Slowly composite materials you may have heard of, which are made out of fibers of carbon and epoxy glue, are working their way into aerospace. That stuff is stronger than aluminum and a little lighter. I don't know how it behaves in micrometeorite impact. The physics of micrometeorite and high-speed impacts are a little bit weird, and things that you might expect to be super strong, like Kevlar. Kevlar is great for a bulletproof vest. It's lousy for orbital debris, just depending on the physics of the material. So I don't think we have anything waiting in the wings to replace aluminum. It's a good choice.
Next question.
How do you guys sleep at night?
How do you sleep at night? Pretty much the same you do on Earth. Maybe your first couple nights in space, you're a little excited about where you are, so you may not sleep real well. But at night, you can just go to sleep wherever you are, and it's really, really comfortable because there's no gravity pulling you onto the bed. But if you just go to sleep floating around the cabin, you will wake up on the ventilation inlet grill because the air currents in the cabin will very slowly pull you over to the ventilation duct. So if you don't want to wake up with all your crewmates on the ventilation duct, you have to do something to kind of restrain yourself. So there are sleeping bags, which you can strap to the wall, and you just climb into your sleeping bag. It has little elastic straps to hold you in, and hang out and go to sleep. So it takes a little getting used to the first couple nights. Some people miss having a force pulling them into the bed. I know a person who, when they're in space, sleeps sort of sandwiched in between two big, huge, heavy cargo bags because it gives them that extra feeling of security. But once you get used to it, it's the most comfortable night's sleep you can ever get.
Next question.
What are the requirements in terms of education and merit to become an astronaut that might be featured on a mission to the International Space Station?
Okay, to be an astronaut, you have to have at least a bachelor's degree in a technical field like physics or engineering or something like that. You can also enter the astronaut corps as a teacher or as a military test pilot. But everybody has to have at least that bachelor's degree plus some work experience or else advanced degrees. Beyond that, you have to be very healthy. You have to be pretty fit. The rigors of working in a spacesuit on a spacewalk are pretty intense. And if you're not in good shape, you're not going to be able to do well at that. So those are the basics, and then the hard part is there's 5,000 other people just like you who want to go do this, and you have to be lucky enough to come out on top in the selection process. But the basics are very simple. They're also on the web. If you look on NASA's website, you can download the job application. It tells you exactly what you need.
You can find that at nasa.gov/astronaut if you want to go do some research.
What is being researched on the space station? I heard something about like biomechanics and microbiology and such, and surface tension for liquids. What all is being researched there?
I certainly cannot answer that question. There are dozens of investigations going on the space station all the time. And you listed the main ones, the main classes: combustion, The way flames work in 1 gravity is very different from how they work in 0 gravity. We're trying to understand how flames work. We're doing work on biology. We're also doing a lot of work on human health so that we can send people, say, all the way to Mars and back and keep them healthy in space. But I'm sorry I don't have a full list for you, but it is a long one.
Next question.
What is the average cost for a mission to, say, the International Space Station?
I don't know, and neither does anybody else. Right now, we're paying about $60 million per seat for a seat on the Soyuz. But the accounting for how rockets are funded and how much they cost and which money comes out of which pot is so obscure that even I with a PhD can't follow it. Cost for an unmanned rocket launch, $50 to $75 million. Soyuz, if you multiply that seat cost times the 3 crew, that ends up at about $200 million. Of course, rockets that carry people are more expensive than rockets that carry satellites because the ones that carry people have to have extra safety systems, which cost money, and more people examining all their parts and making sure that they're really, really ready to fly, because you really don't want an accident with people on board. But sort of hundreds of millions of dollars per launch, or tens to hundreds of millions of dollars, is kind of the ballpark for you.
Next question.
You mentioned ensuring that astronauts were exceptionally healthy. How do you ensure that no particularly nasty viruses or bacteria end up on the space shuttle infecting anyone?
Same way we've done for hundreds of years, you quarantine everybody before they go. So before a crew launches to the space station, they will enter quarantine and they will spend a week to 10 days without contacting basically anyone else. The few people that they are in contact with either have to wear pollen masks or have to get examined by a doctor and make sure that they're healthy. And we've been doing that in the space program, both the U.S. space program and the Russian space programs, for decades, and it works most of the time. We did get the flu on space station one time a few years ago, and the crew got sick and felt lousy for a couple of days, just like happens when you get the flu, and then they got better, just like happens when you get the flu. But we work hard to try to keep the crews in quarantine and isolated from germs so that we don't get any bugs on the space station, because we want our folks up there to be able to work, and we don't want them stuck in bed feeling lousy.
Next question.
And once again, just a reminder, definitely speak up so they can hear you clearly in Mission Control. And go ahead with your next question.
How do the astronauts cope with the speeds used to project them in outer space?
I'm sorry, say that again, please.
How do astronauts cope with the speed used to project them into outer space?
I don't know. How do you cope with the speed you need to ride in an airplane? It seems pretty okay. You know, you're going 500 miles an hour, but you don't feel that inside the aircraft. Same thing in a rocket. Your environment travels along with you, and there is little sense of the speed you're going at, except during launch. During launch, when all those rockets are firing and you can hear the howling of the wind outside the capsule when you're still at low altitude and you're not up in vacuum yet and you can hear that, there is a sense of speed. And the way you cope with that is, and especially the acceleration that the rocket produces, which isn't that great. If you watch a lot of movies, you see people getting, whirled in centrifuges and things like that. The acceleration you feel riding the Soyuz to the space station tops out about 4.5 Gs, which is enough to make you notice. You got to pay attention to your breathing, but you're lying on your back, you're in a comfortable seat, and you just ride there with the rocket, and it's okay. But there's really very little sense of speed most of the time. It's the acceleration you have to think about.
Next question.
When returning back to the surface of Earth, how do the astronauts acclimate to the conditions on Earth and how they differ from the conditions in microgravity in outer space? And do they run into any issues?
Okay, getting used to gravity again is about as hard as getting used to weightlessness at the beginning of a mission. When you first get into space, You have to sort of relearn how to use your body because you don't have your legs as support anymore. You have to, if you're working with one hand, you have to support yourself with your other hand. If you're doing a two-hand job, you run out of hands. Coming back to the ground, then you have to get used to gravity again. Your sense of balance has to rewire itself, so you may feel a little dizzy or even nauseated the first couple of days back. And in fact, your first 3 days back from a short duration space flight, they don't let you drive your car because they're afraid you're going to get dizzy when you go around a corner and crash. So they keep the car keys from you for 3 days when you get back. You may have lost some muscle strength. On my short flight, I actually lost quite a bit of strength, so I had to go back to the gym and work out real hard to get my strength back. We even had a couple people the first day or two back because your heart has gotten used to pumping blood around your body without having to work against gravity. We've had a couple people faint, which always looks alarming, but they've been perfectly all right. Issues, not really, especially now that people are doing their exercises. They're coming back in pretty good shape. In the past, people lost a lot of bone. You can rebuild bone with a lot of heavy loaded weightlifting, things like that. There have been a couple cases where people didn't get all their bone back. But as far as looking at somebody and seeing that they have a health issue, no, people look great. I have a chance now working out in the astronaut gym, see guys when they're 2 days back from space station, and they look really good.
Next question.
You mentioned some physical effects on the muscles and the skeleton. Are there any effects on the immune system, spending so much time usually absent from pathogens?
Yes, although we're getting a little outside my field of expertise here. If you got physics questions, I'm good with that. Biology, that's not where my PhD is, but I'll tell you what I know. So actually there are changes in your immune system, and it has nothing to do with being isolated from pathogens. It has everything to do with being in a stressful environment. People on Earth under stress, like students during college finals weeks and things like that, they get stressed out, and it actually depresses your immune function. That is, things that would not ordinarily make you sick will make you sick because you're working hard, you're worrying a lot, you may not be sleeping too well. And astronauts get that in spades, and that's been the subject of many studies. Now, fortunately, in space, you are isolated from pathogens, so even though your immune system may be weaker, maybe because of the stress, maybe because of something else from being in space we don't really know right now, we have yet to run tests on astronauts in space who aren't working hard. So we don't know whether it's the stress or the space that does it. But because there's no pathogens on space station, or very few because of the quarantine, you have fewer opportunities to get sick.
You mentioned quarantine, but what other things do astronauts do to prepare for space, like physical training or like things they have to do? I don't know. I saw a bunch of interesting like simulations that astronauts have to go through before they enter space.
Yeah, it takes a minimum of 2 years of preparing to fly in space, and for most people it ends up being more like 8. So you're working hard for those 8 years. You're not just sitting at your desk thumbing through the internet. You will be doing a lot of physical training, as you mentioned. You'll be doing a lot of flying in our T-38 trainer jets, which teaches you how to handle complicated systems while moving very, very fast in a situation where if you mess up, you can die. There's training in the giant swimming pool in the spacesuit to learn how to do spacewalks. There's training on the robotic arms, both using real robotic arms and also sort of very sophisticated simulated environments, which has the same joysticks as a video game, but someone's going to give you a stern talking to if you knock your robotic arm into something during one of those sims. There are what we call integrated simulations, where we have crews in mock-ups of the space station on Earth connected to the real mission control with real flight controllers, and elsewhere there's a team of instructors who are throwing malfunctions at the space station every few minutes, and the flight controllers and the crew have to respond to those malfunctions, prevent further problems from happening, and recover from them. So it's a very, very intense and very long training scheme to take somebody who just comes in the door and get them ready to fly in space.
Next question.
When you're up in space, do you have a set area for waste storage, both human waste and food waste, or do you release it into space from the ship?
We do not release waste into space. Our first question, I think, was about orbital debris, and anything you put into space as waste can come back to haunt you at 8,000 meters per second, and we really, really don't want that. We want to dispose of everything in space, or all waste that we generate in space, we want to dispose of so that it does not stay in orbit and then knock out ourselves or knock out somebody else's really expensive satellite. So all of the waste that's generated on the space station gets loaded into one of our several cargo ships that go to the space station. They bring fresh supplies, and when it's empty, they load it up with trash, separate the spacecraft from the space station, and then deorbit it so that it burns up in the atmosphere over the South Pacific, so that even if a few little pieces do reach the ground, there's no people there. It's just open ocean. There are no islands or anything, and even very, very few ships, because the shipping routes don't run under the place where we dispose our stuff. So of our cargo ships right now, we have a handful of them, only the SpaceX Dragon capsule actually lands intact under a parachute, and we use that for returning cargo, but the trash all gets burned up in the atmosphere.
I was wondering how you preserve food in space and keep it from spoiling with things like milk, things like that.
No, we don't get a lot of milk in space. All the food in space has to have a shelf life of a year or more. It all comes up on cargo ships. Those are separated by months. We need to keep a reserve supply of food on space station in case one of the cargo ships doesn't make it. That happened a couple years ago. We had a cargo ship full of food and supplies that crashed while it was heading for orbit, and the crew did not get that batch of supplies, so they had to eat stuff that was in storage. So what we have for food is a whole bunch of freeze-dried stuff like backpacking food, which you add water to. We have a lot of thermostabilized stuff, which is sealed in a package, and then the whole package gets boiled so that it kills all the bacteria, and then the sealed package can remain on the shelf for years. You see those in MREs, the rations that are issued to our soldiers overseas. And then we have some dried foods, and then the best treats anyone can get is when a cargo ship is just getting ready to launch, they'll throw a few things in, like fresh fruit and vegetables, because you don't get too many of those on the space station. And the crew's remark about how wonderful some of those capsules smell when you first open up the hatch and it's got some fresh apples and oranges in it.
What future plans does NASA have for manned missions, and what are some eventual goals of NASA?
Well, right now our stated long-term goal for people is to get people on Mars by the 2030s. Closer to that, we are hoping to get our new human-rated space capsule. We can carry people back into space from the United States, which we have not been able to do since the shuttle retires. And I really hope that we can do that again soon. I'd like to see U.S. astronauts launching on a U.S. flagged carrier. So we're hoping to be flying that capsule with people here in the next 5 years or so. There's some test flights of that coming up without people sooner than that. We've also got a plan to go out with a robotic spacecraft and grab a little asteroid from near Earth space, and we're busy looking for asteroids of the right size right now. Bring that back with the robot ship and put it into orbit around the moon, and then fly up there with people and do some work on that small asteroid. There's going to be some steps in between visiting a little asteroid and going to Mars, and we're still working out what those might be like.
You talked about capturing an asteroid. How do you identify an asteroid? They don't give off any light. Is there any way you can see them?
Well, the moon doesn't give off any light, and you can see that, right? So asteroids don't give off light of their own, but they do reflect sunlight, just like everything else in the solar system, including the moon, the Earth, and spacecraft in orbit. So the problem is asteroids are really tiny. So the moon is a couple thousand miles across, and it's close, so it's easy to see. Now, when you're talking about something that's 1 mile across, or for the size of asteroids that we're talking about now, maybe 20 feet across, and out many times more distant than the moon. It's like a little mosquito that's pretty far from the streetlight, and it's very hard to see. To find those things, we use big telescopes that can, big mirrors that gather a lot of light and wide field of view, so that they're not just looking down a soda straw, but looking at a big area of the sky. And those telescopes, some of which are automated, they do everything robotically. Look for things, identify moving targets. And those guys are busy every night looking at the skies, finding new asteroids. In order to find really tiny ones that are appropriate for fetching back to the moon, we may have to actually build a new telescope. There's one on the books called the Large Synoptic Survey Telescope, which is going to be an 8-meter mirror. That is, the light gathering mirror is 25 feet across. That'll be a good one. And we're hoping that that can identify asteroids like that. Incidentally, that facility and others like it will help identify asteroids that might hit the Earth, which is also a topic of interest. We'd rather that didn't happen. And when we develop the technology to move asteroids around to put them near the moon so that people can visit them, we'll also be developing the technology we need to protect the Earth against asteroids that might strike it.
All right, it looks like that was all the time we have for questions. So I'd like to thank you guys for attending today, and thank you, Dr. Love, for coming in and answering all the students' questions. For the students, do you guys have any final words you want to say?
Thanks.
Thank you.
You're welcome. My pleasure.
Great questions.
All right, great job, guys.